have to go edit more.
That's beautiful.
Okay, great.
And so everyone, I believe we are actually already live. They can, folks can join the audience and so on. Yes.
We have a question.
We have participants. All right. So then I'm actually just going to start because no one really is here to hear me, and I want to make sure we have as much time as we can for the actual panel. So if everyone's okay with that, this is your chance. I'll give you 5 seconds to shout in case you're not feeling ready.
Let's do it.
All right. Okay. Good morning, everyone. It's 5:30 a.m. here in California. We are really excited to be hosting you for this joint plenary panel between UIST and CSCW. This is a celebration of systems research in collaborative and social computing. So we are here at the intersection of these what were originally going to be physically co-located conferences and are now, in adjacent online spaces, one on Discus and one on Crowder. To talk about what's the history, the opportunities of design systems and applications research in social computing and collaborative computing. And I'm really, really thankful that we have an amazing set of panelists here who are going to be doing most of the talking instead of me. So what we're going to be doing is we've organized this session into decades, the 80s, 90s, aughts, the 2010s, and the future, the 2020s, and a pair of panelists who were very, very active in each of those periods are going to be sharing their reflections on that era. So without any further ado, I'm just going to introduce hopefully our first pair of panelists, or at least one of them. The 1980s are going to be represented by Irene Greif and Wendy Mackay. Irene is a co-founder of CSCW, or a founder of CSCW, starting back in 1984. She chaired the first program committee of the conference in 1986. She did research at MIT that then led her into Lotus, where she did a lot of collaborative work, and has won many, many awards. I'm going to be doing very brief introductions. Wendy is hopefully with us at Université Salehi and teaches there. Also did a PhD at MIT, visited us at Stanford for a while, Lifetime Achievement Award for service from Mackay, and many other things. So I will hand it off to Irene and Wendy for the 1980s.
Okay, thanks a lot. Thanks for giving me this opportunity to reminisce and kick off this whirlwind tour of the decades. I entered the 80s as a computer scientist at MIT, moving from parallel processes to distributed databases to office automation. And as a computer scientist, I was still looking at new kinds of transaction management in databases, but I was more interested in what was needed in databases when you were supporting distributed people, and had a newfound concern for the end user, which led me to Kai, but also left me looking for other conferences that were looking more at this intersection of database and collaboration. And one workshop that I ran, as Michael mentioned, with a colleague from digital actually kind of stuck. We invited about 24 people from a variety of disciplines, but all felt that they identified with the term we made up, computer-supported cooperative work. And while we didn't understand each other completely the whole 2 days we were together, we agreed we wanted to find ways to meet again. And an opportunity came up for us in 1986 when Herb Krasner at MCC, a research consortium that had been established in the early 80s in Austin, contacted me to do a conference on software teams. And I suggested we broaden it to computer-supported cooperative work. He said that's okay if please we could just say CSCW instead of that mouthful, and that's how we got started. What I remember most from that conference was, first it was single track, which I still miss. I wish we could live in those worlds. It's not possible, but we had to listen to each other. And not everybody liked everything they heard. And the main controversy I came away with was that there were all these cool systems built by people at Xerox PARC, but only they had used them. And so they didn't seem credible to the social scientists there. The social scientists had done great studies of wide deployments of technologies that were what could be deployed at the time. Character-oriented conferencing, bulletin board systems, things that didn't look interesting to the computer scientists. And so those results were discounted. And that tension seemed to be a lot of what CSCW needed to be about over time, figuring out how to resolve both those points of view. We wanted to stay together and keep meeting though. So in '88, Lucy Suchman at the other part of Xerox PARC, not the techies, led the program committee and took the conference very far in a sort of Scandinavian design mode that probably didn't exactly advance the discussion with the technologist. And we could hear how that tension has played out over the years from other decades. But one thing notable about that year was that Jonathan Grudin, who hadn't even been to on his year in Scandinavia yet, wrote the paper Why Groupware Applications Fail, that eventually became the first lasting impact paper that we recognized for its insights into challenges with managing cost benefits, trade-offs, expectations, and so on. So we definitely did something right at that meeting. And the fact that we're here in 2020 says we did a lot more right. I want to make one more scan through the decade on actually how applications do take off, because we saw two interesting, or I saw two interesting examples in that decade. One was in the early office automation days when spreadsheets seemed amazing, but had been built on sort of hobbyist machines. And then the IBM PC came along, and then Mitch Kapor rebuilt spreadsheets on the PC. And that's when it took off and really changed how people worked in offices. And I feel like I was part of a second version of that. When I joined Lotus and first saw what Lotus Notes looked like as it came out of the lab, it seemed like a conferencing system, almost like the things we had been making fun of. But in fact, building it with a graphical user interface on PCs, robust over flaking networks, which is all that was deployed there, and taking 2 years, as you could see, till it shipped, because it was hard to figure out who was ready for this product. It became the first commercially successful groupware product. Last slide is more to that point, that it's not just technology, but also readiness. In the 80s, the 80s was the decade of rediscovering Doug Engelbart, who he talked at a zillion conferences, including this workstation conference. He had demoed everything we've ever talked about in CSCW. He had built in 1968. Some of you may have seen videos of the demo. I think the more important video is to look at is his talk at the '86 conference on personal workstations, where he talked about that, because you could hear his frustration that people didn't want to take the time to learn to use these wonderful technologies. And it's to that point, you need to bring technology forward when people are ready. And I think we've seen that play out over the years. Any of you who are rebuilding something that we invented back here in the 80s, more power to you. Maybe you'll get the timing right this time. Is Wendy here? Because I'm up to her part.
Yes, I'm here. I'm here. You can't see me in the video. I can see.
You can.
All right. I went to Mackay, and I came from a very different path than Irene. I was an experimental psychologist working with monkeys and language, of all things. And I took a break from my graduate work to go to Digital Equipment Corporation, which was with IBM, the two big computer companies at the time. And at the time, DEC was interested in bringing computers and teaching computers to engineers. I was interested in bringing computers to non-engineers and using computers to teach computing. So that follows nicely from Irene, and also exploring new roles for video. So next slide. So the first thing I did was actually to create online educational courses. This was before HCI was even had a name. And we built a hypertext-like language and ran a group that had bundled courses. So you could buy your computer and it would teach you how to use it. And every single DEC machine at that time had one of our courses on it. Next. But then we see this whole thing. Now, all of you know the story of the IBM PC, the Xerox Star, the Macintosh, stealing things, Steve Jobs, and so on. But DEC was also there at the same time. And there were a number of things that were happening at this point. This is the idea of creating personal workstations in addition to personal computers. Next slide. And so we created something called UIST, which is the first interactive video disc product. And the whole system that we had for educational computing also worked beautifully for multimedia interactive educational software. And that was something that I also I built the software. A woman, Lynn Olson, built the hardware. And then we went to MIT as part of, can I have the next slide? Project Athena, where I was going back to graduate school and restarting a PhD there, but also the liaison between Project Athena, DEC, and IBM. And that is where we continued doing a huge amount of work. So I spent time at Xerox PARC at that time, meeting people like Lucy and so on email and distributed computing things, and then also continuing to do innovative work with respect to interactive video. Next slide. Next slide. Oh, yes. There somewhere. All right. Instead of telling you a bunch of papers, I'm going to tell you about books that were influential, because these really fundamentally changed, and these will go by very quick. The most fundamental from an academic point of view, I think, is Card, Moran, and Newell and the Psychology of Human-Computer Interaction, which changed how psychologists think about it. Then, yes, Sherry Turkle is next, and she looked at how we, at MIT, and looked at how computers change the way we look at ourselves. Next, we have Lucy Suchman at Xerox, and an anthropologist coming in and looking at challenging the way that we think about artificial intelligence and thinking about the role of context and design. And we have another challenge to AI in the next one, which is Winograd and Flores, Understanding Computers and Cognition. At the time, Terry Winograd was a major voice in AI and then shifted into human-computer interaction. After that, we have what's probably the most famous book, which is Don Norman's Psychology of Everyday Things. Notice the name, we used to call it POET, but now you all know it as the Design of Everyday Things. And that was not an academic book. It was really forcing us to take the user's perspective. And finally, we have Shoshana Zuboff's book. She was at Harvard and she did In the Age of the Smart Machine. And that really looked at an extensive academic study looking at how computers are changing industry. So there's this huge intellectual force coming at that decade. Now, can I have the next slide? All right, so there were a whole series of conferences. We've already heard about the creation of CSCW. Kai went international very quickly. So there was Kai plus Guy, the Graphics Institute in Toronto. There was UIST, which is really a spin-off from people who were trying to publish at SIGGRAPH and could get SIGGRAPH interested in interaction. So they created UIST and Banff. And at this time there were, and you see here, this is a little plug for Catherine Plaisant's collecting of the videos from all this decade. And here, can I have the next slide? So what was happening at that time is that I was involved in creating the first local SIG, which was Greater Boston SIG Chi, and then I was on the executive committee as treasurer and then chair. And we're thinking about how do we create a community? What does the community look like? And we started out as psychologists and computer scientists, and then it moved into graphics and moved into anthropology and sociology and business and a wide variety of things. So can I have the last slide? So what we were doing at that time as part of the executive committee is setting the ground for a number of major innovations. We did the first long-range planning in the late 80s, and we looked at, we're going to create transactions on Kai, we're going to create interactions. We were a major force behind the digital library. We're one of the SIGs that really actively supported it. And so all of those things happened in the 90s, but I wanted to mention that we were really thinking about that in the 80s. And I think I will stop there and hand it off. So there was me then and me now.
Excellent. Thank you to our panelists from the 80s. I want to remind everyone that there's an open Q&A forum at Slido or Slido. You should have links from that in coming out from your respective conferences. We are now going to trade our neon for umbrella pants with the 1990s, where we're very excited to be hosting Jonathan Grudin and Hiroshi Ishii. So Jonathan is a principal researcher at Microsoft. his paper, Why CSCW Applications Fail, that was mentioned in the prior session, won the first Lasting Impact Award from CSCW. Hiroshi Ishii is faculty at the MIT Media Lab, who founded and runs the Tangible Media Group. His early work on collaborative systems and then the classic Tangible Bits led to, among many other contributions, the Lifetime Research Award this past year from ACM Sig Chi. So Jonathan and then Hiroshi, please take it away.
Thank you. Welcome to the 1990s. One or more cooperative support papers appeared in UIST each year. Some authors of all these attended both conferences. The most important year for CSCW was 1995. In 1985, there were only 1,000 internet hosts. CSCW was a small community, homogeneous, highly trusting. Online anonymity was rare. Commercial activity was prohibited. In 1995, Netscape brought the web to the public and commerce was allowed. The internet bubble formed with 250 million users in 1999. Anonymity enabled spam, viruses, worms, denial of service attacks. CSCW conferences formed in Latin America and China. Like European CSCW, they focused on systems and organizations. In 1990, CACM asked me to put together a CSCW issue, 7 articles, industry and academia, technology and anthropology, social and cognitive science, North America, Scandinavia, and from Japan, a video conferencing paper co-authored by Hiroshi Ishii. Let's look at video through the 90s, beginning monochrome and ending color. This is the first session of single track CSCW 90. Talks from 3 telecoms, Belcor, NTT, and NEC. The first CSCW 92 and 94 sessions were also video. More video presentations in other sessions, Keio University, Sun Microsystems, GMD in Germany. Many research systems. Some became unsuccessful products. Not all relevant work was about design. Christian Heath and Paul Luff were influential ethnographers. Jim Holland and Scott Stornetta's Beyond Being There challenged the field to think beyond just replicating face-to-face experiences. And we made it. What can we learn from how long it took? Collaborative writing. Turing Award Doug Engelbart, mentioned before, loved CSCW and discussed hypermedia in 1990. Christine Neuwirth presented in 4 CSCW conferences in the 90s. UIST was drawn in. Cheng Zhang Sun's brilliant CSCW technical work led to a product you know, Google Docs. Theory and values. Some European researchers read Heidegger and worked with unions. Tom Malone's coordination theory was new. Existing social science theories were applied. Lynn Marcus identified sources of groupware failure that I missed in 1988. My most cited paper in the 90s integrated this. Andrew Clement's clever cooperative support for computer work shifted the focus to user empowerment and Scandinavian participatory design. In 1992, it was so exciting to be able to see actions of distant collaborators. The quotation reveals that in the small, trusting CSCW world, watching colleagues without them knowing seemed good. Awareness papers flooded CSCW and UIST. The second most cited CSCW paper is Paul Durish and Victoria Belotti's 1992 analysis of collaborative writing systems. In 1992 and 94, Wanda Orlikowski and Mark Ackerman published influential studies of groupware use in organizations. CSCW found a synergy with eCSCW, which focused on organizations that had begun adopting the commercial applications of the type CSCW researched. Ethnographers helped both. The most cited CSCW paper is the 1994 collaborative filtering system by Paul Resnick and colleagues at Minnesota, based on Usenet NetNews, perfectly timed for the rise of the web. The third most cited is a follow-up. Patty Mace was another influential inventor of collaborative filtering and intelligent agent systems. Finally, circling back, the first ECSCW paper of the decade was Kjeld Schmidt's wonderfully titled Riding a Tiger, or Computer-Supported Cooperative Work. In 1995, vastly more powerful tigers were unleashed, and the question is, can we control them? Next, Hiroshi Ishii will describe his path through the 90s. Thank you.
Thanks, Jonathan. Also, Michael, for this amazing opportunity. Can you hear me? So today, I'd like to go quickly about the endeavors to really make exciting use of the videos, as Jonathan already highlighted. In 1990s, there's a lot of the amazing hype about information superhighways to make a broadband multimedia networks. And a bunch of the telecommunication giants jumped on these bandwagons. NTT is one of these companies which I worked for in 90s, in which we try to create new values of the broadband ISD networks to adding a new application and service. So I focus about real-time bidirectional videos. Then how to use the videos most interesting and effectively is one of the key idea. So we came up with the idea of how to translate this video overlay, which enable people to mix the physical world and also digital world. Now you can see computer screen, but it can be also fused with the desktop videos, physical object, paper or hand gestures. Also, you can easily move your personal application into shared screen from left to right. It's something we are doing in the Zoom for every day. 1992, our team co-invented the ClearBoard to address another issue of the theme, to really connect the interpersonal space and also shared drawing surface seamlessly. Now you can see I'm drawing in one terminal, but my colleague can see where I'm looking at. It's called gaze awareness. It's beyond eye contact. So while you're talking, you can naturally shift your focus or gaze between shared drawing surface and also the interpersonal communication space. And I have a great opportunity to work with Jonathan Grudin, also our common great friend, Naomi Miyake, to understand, analyze the meanings of the gaze awareness in this context of remote collaborations. As Jonathan also pointed out, there's so many exciting work in 90s. Some came from 60s or 80s, but video draws, collab meeting rooms, media space, those all from Xerox PARC inspired us a lot. Also, our heroes, Douglas Engelbart, NLS, 1968 demo, really sheds a light to the futures. Also, Beyond Being There by Jim Horan and his colleague really challenge us. Unless we create a new value, you're just imitating the physical co-presence, you never really succeed. So gaze awareness of ClearBoard is one of the answers to this challenge of Jim Horan. Also, interpersonal distance, studied by Edward T. Hall, has a very important implication for our design. So I think we can really challenge to the new proxemics, so that how we can define and control the proximity in the era of the hybrid multimedia teleconference environment with video and groupware. So 1995, I moved from NTT to MIT Media, then started the Tanju Media Group, focusing about basically try to make digital tangible. Not only the document or data, but also the presence of remote people. I want to make it tangible. So we did a lot of the groupier stuff. This is one of the early groupier called Ping Pong Plus, changing a ping pong table to collaborative fun experiences by augmenting. And the tangible reference is really challenge how to reinvent distancing. We don't have a distance control of the distance today because of COVID-19 crisis, but I really want to bring the connectedness among people separated spatially, temporally, and emotionally. This emotional aspect seems something very, very important. These are in-touch systems that we demonstrated in CSCW long ago, but you can see two devices synchronized. By touching, rotating, you can see another rollers also spin. They are connected by mathematical spring. So you can convey the sense of touch, like a tone of voice in a telephone. This is a way to connect the people using a sense of touch. This is another way to connect the workspace, remote tabletop tangibles. We can synchronize so that people can also work together to go beyond sharing screen or pixel. So I presented in CS98 about the framework of tangible interface for remote collaboration and communications. But the interesting stuff is between HCI, also CSCW, we can use tangible interface in both areas, and especially for CSCW, synchronized distributed physical object, I call teletangible, can really support shared workspace, but also interpersonal space. That's something quite interesting. I went to the radical atoms after those work. Then we designed Inform with Daniel Reitzinger and also Sean Former. So this is a futures of tangible telepresence we envisions. Then we are very excited to see many people got resonated. I got one tweet about this one, the future of Zoom underbar US. So thank you very much for the opportunity to share the history of the video mediated remote collaborations. Thank you.
Thank you, Hiroshi. Thank you, Jonathan, for representing the 1990s. We're going to be moving forward from the 90s to the aughts, from the information superhighway to Web 2.0 and the rise of the social web. We're very excited to be seeing Karahalios and Mary Morris representing this decade. Karrie is a professor of computer science at UIUC. Recently, she's been doing a lot of work blazing a trail on algorithm audits. She's a Sloan Research Fellow and many other recognitions. Mary Morris, likewise very decorated, a senior principal researcher at Microsoft Research and a research area manager for interaction, accessibility, and mixed reality. She was incidentally one of the first HCI researchers I ever met when I was an undergraduate and she was a PhD student. She's an ACM Distinguished Scientist, Chi Academy. Mary and Karrie, please take it away.
Great, thank you so much, Michael. So today, Karrie and I are going to reflect on the first decade of the 2000s. One of the first themes that we saw spanning UIST and CSCW in this decade is the emergence of new multi-touch form factors that could support co-located cooperative work. So at UIST 2001, Mitsubishi Electric Research Labs introduced the Diamond Touch table, which allowed for multiple simultaneous user-identified touch points based on users being capacitively coupled to the table. And this new hardware kicked off a lot of research in the CSCW community in terms of understanding how to best design for these multi-user co-located settings. So at CSCW this week, Stacy Scott's 2004 paper on territoriality in tabletop workspaces received the Lasting Impact Award. And here, Stacy and her colleagues studied the ways in which people used this emerging form factor and identified the need for both shared and private spaces. And indeed, we also saw innovation from CSCW in the hardware itself to support these needs. So from Japan at CSCW, we saw the LumiSite table, which innovated by using a Lumisty film that only transmitted light at a certain angle, and they layered 4 sheets of this film at 90-degree angles on the top of the table, and then had 4 projectors underneath at different angles, so that depending which side of the table you are on, you could have both a private space as well as a shared space in the center. And then the UIST community continued to innovate on form factors as well. Jefferson Hahn's work on frustrated total internal reflection as a low-cost method for developing multi-touch tables was recognized recently with a UIST Lasting Impact Award. And this kicked off a DIY effort in the tabletop community where students at universities were building their own FTIR tables to scale research in this area.
And moving from large surface displays to smaller surface displays. In the work by Hinckley, Pierce, Sinclair, and Horvitz at UIST 2000, we see mobile devices enhanced by sensors in addition to touch-sensitive screens. And while we had hints of one-to-one mobile interaction in the industry with the Newton and Palm Pilot prior to 2000, key ideas like reorienting displays when the phone is tilted begin to emerge, as well as collaborative applications in early augmented reality games and research, such as Bragfish, an augmented reality fishing game. In addition to sensing, we also start seeing advances in keyboard input for speed, like Sharp, that inspired shape writing and swipe systems that made their way into mobile phones and supported faster interpersonal communication in CMC systems studied by researchers at CSCW. And many of the key research interaction and hardware concepts from earlier in UIST, work such as multi-touch finger-sensitive touch screens, are operationalized in Apple's iPhone, introduced in 2007. This and similar phones became important platforms for next-generation CSCW and social computing research. We begin to see the phone emerge as a platform for citizen science initiatives, communication, gaming, and other collaborative efforts, with ubiquitous cameras on phones becoming important for fueling user-generated content that led to Web 2.0 and social platforms.
Another theme that emerged during this decade was the emergence of platforms to gather information from the wisdom of crowds, which could create new tools for both evaluating and ultimately powering user experiences. 2001 marked the debut of Wikipedia, and this is the beginning of a thread of work that aims to democratize information production and consumption. So we see the CSCW community in this decade increasingly studying communities on Wikipedia. For example, this 2008 paper from Nikki Kittur and Bob Kraut. And Wikipedia really became an ecosystem to study in and of itself, to understand how the technical capabilities of the platform shaped participation in and cultural norms of this online community. Another important development in this decade was the emergence of human computation. We're cheating a bit because this is a Kai paper and not a CSCW paper, but it's a very important one. So in 2004, Luis van Aan and Laura Dabish published about the ESP game, which motivated people to provide metadata describing images on the web by creating a taboo-style online game. And this kicked off the field of human computation, which also became commercialized in this decade. So in 2005, Amazon launched the Mechanical Turk crowdworking platform, which also became integral to HCI research. So again, at Kai in this decade, we see Nikki Kittur and his colleagues demonstrating that Mechanical Turk could be a useful platform for the evaluation component of HCI, noting that there were pros and cons of the platform, for example, in interpreting the quality of the results. And we see an emerging study in the CSCW community, just like of Wikipedia, of the study of Mechanical Turk as an ecosystem in and of itself worthy of study. But then as the decade comes to a close, we see the UIST community looking not just at how we can use crowd platforms for evaluation or to study in and of themselves, but how we can use them to power new user experiences. So at the close of the decade, we see Jeff Bigham and his colleagues publish the VizWiz system, which innovated in using a retainer model to allow for nearly real-time crowdsourcing so that people who were blind could capture images with their iPhone and have them described within 1 minute by crowd workers.
At the beginning of this decade, we start also seeing seminal work by the Olsons in Distance Matters, and we continue to see research and product expanding beyond computer-supported cooperative work into areas of social interaction and play. 2004, oh, actually, one slide. We see the study of social dynamics extend to multiplayer games, as we see in the CSCW 2004 paper, which is showing us a Star Wars Galaxy game. And this research offers in-depth analysis of player-to-player interactions and how to understand and support rich social activity. And we see similar work in this area in games such as World of Warcraft. 2004, we see the debut of Facebook at Harvard with an expansion to other universities shortly thereafter and to the public in 2006. And while originally fashioned after a yearbook-type metaphor similar to predecessors like Friendster and MySpace in 2003, it facilitated movement of identity representation online from the personal homepage to the social media site for a wider audience. And it took a step further with the wall, later called the newsfeed. It was initially met with outrage. It changed the nature and frequency of viewing and later changed advertising in 2007. And that same year, they introduced a platform that brought us games by companies such as Zynga. And then from them, we got the like button. Other forms of feeds can be seen in Dig in 2004, Reddit in 2005 to let users discover, share, and recommend web content. Both had systems where you could vote up a post or vote down a post. And such sites provided a platform for CSCW work to research the mitigation of trolling, harassment, disinformation, misinformation online, and later inspired the creation of platforms to study such phenomena at scale. And here we also start to see the emergence of the algorithmic feed. 2006 brought us Twitter that asked people, what are you doing? And showcased a customized timeline view of tweets in reverse chronological order that led to both UIST and CSCW work in mining social media, predicting sentiment, stock markets, live tweeting sports events, movies, and more. Also, these large platforms also led to research questions that provided a space to investigate them. In the CSCW 2008 paper by Lampe, Ellison, and Steinfeld, they began to examine whether people really used Facebook as an advertise to grow their network of new contacts or to socialize with existing strong ties. And let's not forget the prevalence of tagging in this decade. People tagged photos to help others find photos in Flickr, tagged bookmarks to share sites on Delicious, and in the process created folksonomies that CSCW researchers studied and that UIST researchers built upon. For example, in this 2009 UIST paper by our host, Bernstein, with his colleagues, that brought together human computation and social networks to produce novel metadata through friend sourcing, a form of crowdsourcing that takes place as unpaid work motivated by games and social interactions. In this decade, we saw large-scale social computing systems with user-generated content taking off, which some referred to as Web 2.0. CSCW focusing increasingly more on studying dynamics of these systems, and UIST focusing on creating systems. CSCW and UIST began to grow apart in this era. We hope that this joint UIST CSCW conference kicks off a new decade of collaboration across these two communities to address important societal changes together.
Excellent. Thank you so much, Mary and Karrie. We will transport ourselves a further 10 years into the future, into the 2010s, where there's been a massive growth of computing and information sciences, and going, yes, from the rise to the fall from grace of social networks. And we're going to be toured through this decade by Jaime Teevan and Kittur. Jaime is chief scientist for Microsoft's Experiences and Devices division, where she basically is creating the future of productivity. And she started working on search engines before most people knew what a search engine was or why it was going to be important. And she's a TR35 Young Innovator, many other awards. Kittur is Cooper Siegel Chair in the Human-Computer Interaction Institute at Carnegie Mellon University. He's a Kavli Fellow. His work has shown up in Nature News, The Economist, many others. Also, as with all of our panelists, highly awarded. We're excited to hear from both of you, Nikki and Jaime. Take it away.
Great. Hi. So Nikki and I really enjoyed the important transitions that Mary and Karrie highlighted in their presentation. And so we pulled them all out onto a timeline. And there's sort of three significant technology trends that UIST and CSCW were a part of and contributed to and built from, sort of one around mobile and connected systems with the emergence of the smartphone. The aughts also saw the emergence of cloud services like AWS and Azure. We also saw a real explosion in online data, and in particular of user-generated content in the form of social media and news feeds, but also like 2006, we saw the start of YouTube and video content really becoming available at scale. And then finally, there was this trend of the emergence of platforms for distributed work, like Wikipedia and Mechanical Turk and various other crowd platforms. And like, as we look into the past decade, into the 2010s, we see that these trends have accelerated. And so it's in the work, and the work that we're doing as a community to push boundaries as relates to these trends are really important. But something interesting has happened also, where these trends have started to come together and like mix together to produce something new. And so as you extend out past the emergence of Facebook and past smartphones and past Mechanical Turk, you see something really interesting start to happen with the data that gets produced. So 2010 represented the very first ImageNet challenge. And ImageNet is a platform that was used for training AI systems. And one of the real innovations with ImageNet was that it was able to produce data at scale. So when Feifei started creating ImageNet, she was paying graduate students to collect data, and that just didn't scale. And the emergence of these online platforms to use crowd workers to scale the data really changed the kind of research that people were able to do. And then in 2012, you see AlexNet win the 2012 ImageNet challenge with CNNs, and that's really the start of the deep learning revolution, you know? And this whole decade has been about the AI revolution. But it's not really an AI revolution, even though that's the way a lot of people think about it. It's really a data revolution. It's really an interaction revolution. And like, as UIST and CSCW, we're the community that gets to connect the people and the data and the algorithms to look at how this revolution is changing the way people get things done and the way we interact with our systems. Now, at the same time that this is happening, that we've seen mobile and connected systems and the explosion of data and online platforms change what our computers are doing, Nikki and I were undergoing our own more personal transition with little children. So these 4 boys, naughty boys, are my kids, and this baby here is Nikki's daughter. And like Griffin, my oldest, the one in the middle, when he was born, none of these things existed. Smartphones didn't exist, Facebook didn't exist, Mechanical Turk didn't exist. And 4 years later, when my youngest, Briar, was born, all of it did. And like, as we're going through this tech change, like there's this, like, kids just change everything. Like they change the way you view anything. And like, as the world is starting to show increasing concern around like the impact of these technology changes, like about distraction and like, is having our phone everywhere and social media everywhere causing us confusion, you know, Nikki and I were realizing you just can't avoid that distraction. It's inevitable. You've got a bunch of little babies. Like you have to be able to drop everything and context switch at the drop of a hat. And so this combination of kids and technology fundamentally shaped our view of productivity. And like it led to us, as we reflected on the research of the past decade, to see that like, while it became possible to work from anywhere and at any time, it became really hard to focus. And the cool thing is that as a community, we were learning how to make even small bits of scattered effort add up to something big via crowd workflows and as training data via artificial intelligence. And so that led us to conclude that the 2010s, the past decade, is the decade of fragmented intelligence.
So the idea behind fragmented intelligence isn't new. You know, if you think about it, our own minds are made up of fragmented systems that specialize in different kinds of intelligence. And UIST and CSCW researchers have been looking for decades at ways of embodying that intelligence in our environments and in our computing systems. But the trends that Jaime introduced cleared a path for fragmented intelligence at a global scale with an enormous set of opportunities, which we'll talk about kind of grouped into 2 forces. So one of fragmenting intelligence, in which people can work anytime, anywhere, in increasingly complex socio-technical architectures mediated by machines. And one of gathering that intelligence from those fragments, where bringing together a diversity of perspectives can lead to amazing creative artifacts and where machines can learn from and become more intelligent themselves. And as we dive into these, there's much, much more work than we can possibly talk about, but we'll highlight some examples of threads of research that have happened in this past decade. So the first is about fragmenting human intelligence. So systems for working anywhere, anytime have taken off over the last decade. We've seen opportunities to use micro moments of time to assemble enormous artifacts like Wikipedia. and the potential of being productive no matter where you are or what device you're using, whether it's a laptop, a phone, or even a watch. But we also see the perils of people turning into cogs in the machine. So next slide. Work bleeding into life with no boundaries, social structures, or growth opportunities. And that led our community to ask questions like, what would it take for us to be proud of our children growing up to be crowd workers? And many researchers answered this call, building systems enabling crowd workers to get mentorship, skill up the career ladder, and build lasting social connections. But turning these micro moments and weaving them together into productive work is only possible if we can algorithmically decompose and reassemble them into more complex socio-technical architectures. And there was an enormous amount of work on how to do this in the past decade in both UIST and CSCW. In fact, we needed 2 slides to even start to begin to capture that, and we've left a lot off of here. This is still a teaser. So we started as a community looking at opportunities for incorporating human intelligence as APIs into our systems, dealing with issues such as getting real-time and reliable answers from the crowd. And this led to full-on crowd-powered systems where crowds could be seamlessly integrated into interfaces that could shorten our papers or be truly intelligent assistants. So next slide. However, these systems brought up a fundamental problem. How can you have a globally coherent system despite each person seeing only a tiny slice of the whole picture? And our communities attack this in many different ways, such as designing scaffolding into the system itself, or by appointing crowd leaders who could have a big picture view. And this led to increasingly complex and subjective tasks being done in this fragmented way: journalism, creative writing, prototyping, design, and systems that would explore a diversity of scales, whether it's a team of 1.5, which is you and your future self, or entirely fragmented organizations. Moving on to pulling together intelligence from the fragments, we've seen 2 complementary trends here. One which is taking advantage of the diversity of independent perspectives, so for example, to generate many different kinds of ideas, and another which is actually breaking that independence by enabling people to build on each other's ideas and unlocking the power of remixing and reuse. So next slide. The problem here, though, is if the crowd doesn't have enough expertise or understanding to be effective, it doesn't matter how many people you put together. But our community still found ways to turn that weakness into a strength by having the crowd improve itself, or by compressing the crowd's history so newcomers can get just the knowledge they need. And then finally, we see a lot of opportunities for AI systems that learn from humans. So once we have that intelligence fragmented and externalized, we have a treasure trove of data for AI systems to learn from. We can use that human intelligence to help machines deal with sparse or subjective data, or to learn what are the really important causal features in the data. Next slide. However, no matter how smart AI gets, there are going to be failure cases, whether inaccuracies or biases that get encoded into the data. And here we've seen approaches such as fragmented automation, with the AI automating the easy cases and failures getting kicked over to people who can teach the system how to fix itself. But the design space for dealing with AI failures and biases is still wide open, with lots of challenges and ethical issues left to solve. These are thorny questions we're just starting to tackle and will be critical to unlocking the power of AI for good.
And so all of this work that we've been doing as a community is fundamentally about breaking down the boundaries that people have with respect to time and space by fragmenting work into pieces, so that it doesn't matter where you are or when you are or how much time you have available. You can bring your unique insight to bear. And recently we've experienced a really significant disruption to the system with a rapid shift to remote work. And we're entering into a future where all of this that we've seen in the past decade is going to be accelerated. All of those opportunities that Nikki mentioned and all of those challenges, it's really our responsibility right now to bring this work to people, to make sure that people don't get lost in the system. and to figure out how to merge synchronous and asynchronous work so people can work with different schedules or go off and watch their child and still participate in the things that are happening real time, and to figure out how to build the boundaries that we need as these boundaries break down to support well-being and an ability to focus on the things that matter.
And not to get too meta here, but the communities that we're part of are themselves a big system of fragmented intelligence, with the work that we're all doing happening in a fragmented way for the last decade. But now we need to start putting this work together. We need to start having a big picture view ourselves. And if we do it right, just maybe we can use these ideas of fragmented intelligence to build a society that we all want to live in. Thank you.
Thank you, Nikki and Jaime. We now turn to the future. So we have Amy Zhang and Niloufar Salehi representing what I was initially intending to be the whole sort of upcoming decade. Now it sort of feels like 2020 has been long enough to be a whole decade in and of itself, but they're going to be representing where are we going from here? Amy is an assistant professor at University of Washington's Allen School of Computer Science and Engineering. She recently was awarded the George Sproul's Best PhD thesis at MIT in computer science. She just began her faculty career at UW and is, I'm sure, recruiting graduate students. Niloufar Salehi is an assistant professor at the School of Information at UC Berkeley. She's a leader in participatory and critical design in social computing. I'm sure she's also recruiting graduate students at UC Berkeley. Again, both of them also very highly awarded. We're really looking forward to them thinking about where we go from here. So take it away, Amy and Niloufar.
Okay, so Niloufar and I were given the easy task of talking about the future, no biggie, but we thought that what would be really interesting here would be to actually poll people in the CSCW and UIST community about their answers to this question. What will be the biggest challenge for social system design in the coming decade? So we posted that question on Facebook and Twitter, received 62 responses. We then went through and open coded the responses and then grouped them into 3 main themes. So obviously this is not a rigorous study, caveat. And also people talked about a lot of interesting things, but in the interest of time, I'm just gonna go ahead and focus on these kind of 3 main things that jumped out from people's responses. So first off, there were several responses about how we could engage more directly with human and societal values like democracy, agency, privacy, inclusivity, sustainability, et cetera, in our research questions. And I just want to say that there are definitely already people working on these topics, including people in the panel that you've heard from, but from these responses we received, maybe they're suggesting that we could focus even more on these questions in the coming decade. So just as an example, several of the responses mentioned democracy, very relevant today. So here's a quote: "I wish the current reality didn't bring me to this thought, but what can our research community bring to the table to not only understand, but actually implement solutions to protect it?" Other people mentioned areas like human agency and privacy. This came up quite a lot. So navigating the trade-off between systems that amplify human nature versus systems that manage to control/direct human nature. Other people also questioned our existing design principles, such as scale. Scalability is a harmful design principle. Instead of only does it scale, it should have at least a little bit more nuance, like who benefits and who is harmed when it scales. And actually there was a workshop on reconsidering scale at CSCW just a few days ago. Speaking of harms, we did get a lot of responses about harms that systems can cause to stakeholders. This is very current in our community conscience. So how do we account for misusability in design and development? We now have abundant examples of computational tools and systems with harmful side effects or abuses. Our humans need help to better brainstorm and account for these effects. So second, we also had many responses that spoke to this question of what are our unique opportunities as researchers to have broader impact when there are these kind of dominant industry social systems in the world today. So several people argued that we as researchers have a unique role to be able to do things like engage in longer term thinking. We have the freedom as researchers to build systems that can be open and in the public interest. We can and we should tackle more complex and evolving systems that involve many stakeholders. So this quote said, "I think we still haven't yet come up with great answers for how to best design within complex systems, e.g. healthcare. Constant questions when in a complex socio-technical system include, who are the stakeholders? How are we developing the goals of our innovations? And who do those goals prioritize at the end of the day? How can we make robust systems that last over time and can be fixed or reworked for the future?" People also talked about considering a wider scope of our work and engaging in more interdisciplinary work or collaborations, such as having something to say about public policy or economics or the design of new business models. This person said, "I think sustainable business models, especially in large incumbent platforms, are a source of concern. What can we do? One, study these problems and methods directly instead of indirectly implying their issues in our papers. Two, include system scale incentive model considerations in our own research and system designs. Three, highlight long-term sustainability within our own work and our research products." And then finally, there are also many responses that then looked inward to our community and asked, how should we reconsider our current approach to conducting and evaluating systems research, as well as what we want to encourage and reward as a community. So for instance, people talked about refusal. When should we actually not find a social system? And actually I attended a really relevant panel that happened yesterday that was actually co-led by Niloufar on this very topic. People also talked about not solely focusing on novelty. So the focus should steer away from only caring about novelty to more broadly focusing robustness, resilience, and usability. The topic of maintenance came up, kind of echoing earlier points about longer term thinking. CSCW systems seem often holistic in scope, yet rarely endure, either because it was Wizard of Ozzy or little external validity. It's probably an unfair criticism because academic systems doesn't give time for good code, but the bit rot that happens with some of these amazing systems is unimaginably bad. The artifact matters. And I thought I would end with this last quote here about slowing down. Time. Nobody in academia or industry is given or takes the time to design social systems carefully. We need to slow down, but every incentive structure speeds things up. You can develop shared ownership of a platform among diverse stakeholders. You can do more thoughtful, rigorous, long-term and participatory research. You can force others to reconsider why they must move fast. Okay, and then now I'm gonna hand it over to Niloufar.
So we thought it would be very cool to take some of these values, approaches, and insights that we got from the community and go look at the papers from this year from CSCW and UIST. And we highlight a few of the papers that we thought were really interesting to think more about. So the first thing that came up was values. And one of the really salient values that people talked about were democracy, participation, and governance. And we actually had two papers this year that talked directly about this. So the first one is Policy Kit. It's around the governance of online communities. It's a system that basically allows members of different online communities author a wide range of governance procedures and then automatically carry them out. So users can encode these different community governances into policies or short functions that specify a procedure and then determine whether a user-initiated action like posting or moderating a message can actually execute. A really interesting thing about the system is that it also predicts that there are going to be changes to policies over time. And so it gives people the opportunity to also basically edit the policies themselves. The second paper is Community Click, which looks at traditional town halls, which are still extremely common, and now they're all online, but they're still the basic method for community consultation and different kinds of democratic governance. So what the system does is it looks at the problem that a lot of the people who participate in town halls don't actually get the opportunity to speak or provide feedback in an inclusive way. And so they've built a system that basically takes iClickers and extends their capabilities and gathers lots of information from people participating in a town hall-like setting into basically a meeting transcript that offers a summary of everything that's been spoken about and what people, attendees and organizers thought about it. A second value that people talked a lot about was accessibilities. And there was a really interesting paper called Rescribe that enables audio descriptions of videos. So what it does is it allows authors to talk about, basically describe what is in a video, and then it automatically finds gaps within a timeline or a transcript for a video where those descriptions of actually what is seen can be inserted automatically. And then it creates compositions of these descriptions, and it allows people to edit them if they want to. Next slide. Another one was a tangible user interface that allows people who are blind or visually impaired to actually develop and design web layouts without external assistance. Another thing that we really liked about this was actually a poster at UIST, is that it uses interviews and co-design sessions with a blind participant to actually design the product and to guide the design. So this is a good segue into the next section, where a lot of people talked about our general approaches to design and how we go through that. But these are some of the values that through the process that Amy talks about, we heard a lot from the community, values that they want to see more embedded more into the systems that we design. So some of them are democracy, participation, governance, and power. Accessibility was really important. A lot of people talked about harms, misuses of technology, things like misinformation, labor exploitation, bias, and I think that we have a lot of work to do as system designers to think about how do we mitigate these things before they happen. Privacy and transparency were really important themes. And then, as Amy mentioned, there was a larger need to think more broadly about how these systems actually get implemented in the real world, thinking about sustainability, both environmental and socio-political, thinking about business models, law, and policy, and how do those affect the systems that we build and what they actually do in the world. Another thing that people talked a lot about was approach. And again, we picked two papers that we thought were really interesting in this regard. So the first one is a paper that co-designs and evaluates an intelligent decision support system for stroke rehabilitation assessment. And this paper does co-design with actual people within a hospital who work with rehabilitating patients. And they found some things like there are different performance components when you think about motion, like range of motion, smoothness, compensation. And so they gear their system towards these things that are really relevant to how things actually work in a healthcare setting. And the second is a participatory machine learning algorithm system that was embedded in Wikipedia for over 5 years. Again, this approach of thinking about a system within the context of a larger socio-political technical configuration, and how does it actually get used, and how can we open and broaden participation is really interesting. And I wanted to end with another approach that a lot of people talked about, which is refusal. And as Amy said, we talked about it at a panel yesterday as well. I personally think that it's really interesting to think about what does it mean for refusal to be a research contribution. And this paper doesn't exactly refuse medication adherence apps, but it does open and broaden our understanding of what are the needs of people who use these apps, for instance, for HIV-related needs. And it talks about a lot of the same themes that we talked about so far, needs for privacy, trust, intimacy, and social support. So to wrap up, people talked a lot about embedding values like democracy, agency, privacy, inclusivity, sustainability, and thinking about the harms of systems. They talked a lot about thinking about long-term impacts, and also about reevaluating our approaches, like how do we evaluate systems, how do we slow down in building them, and how might we sometimes need to refuse them. Thank you.
Thank you, Amy and Niloufar. So I think where we're at right now is I believe that there's actually the start of a joint social between UIST and CSCW, but we're going to go beyond being there because I want to make sure there's a little bit of time for questions. So you can attend that. If you'd like to stay for a few more minutes, I'm going to peel off a few of the questions from the Slido or Slido If there's a link in the Q&A from Zoom. Our code is R268, which is the less loved Star Wars droid. And I'll toss out a few questions for the panel to chew on. The first one by Anhuang asks, it says, many of them mentioned most impactful work were commercial systems from companies and industry labs. What's the role of academia versus industry and innovation at the intersection of WIST and CSCW? So what are we doing here when you see these innovations often coming from startups or from industry? So I'll hand that over to the panel to chew on.
I can start with some of that. I think at least with some of the touch-sensitive interfaces, you see a lot of work from WIST happening at least a decade before we start seeing it in product. So you start seeing that type of innovation stem from research into industry. A lot of what you start seeing in industry that's fascinating is that the mass quantities of data. So for example, a lot of the data that you see at Google enables you to do certain types of things that might be harder to do in a research lab, but that startups can slowly start doing over time.
Yeah, I'll follow up also just from the industry perspective too. Like, it's certainly true that we're seeing a tighter coupling of industrial and academic research for exactly the reasons that Karrie is sort of talking about, the ability to deploy things at scale and the importance of understanding the externalities and the long-term impact of that really speak to the need for a close alignment between the two communities. And, you know, at Microsoft, we actually made up my role as chief scientist in part because of that need to connect research more directly in product and also connect our products more directly with the academic community in order to understand sort of the long-term impacts and to be pushing on us to think about ways that are you know, that look to the larger societal implications.
Can I say, there's another thing that's happening, which is that industry hires people who come out of academic programs. And so there's this really important link between researchers who are creating new ways of thinking about things and showing different directions and challenging ideas, and then having that affect students who then go and are hired in industry and then change the people around them. And initially they have perhaps low power, but they move through the system. And so we've seen that again and again and again. And a lot of the innovations from the early days were things that actually were done in research labs and then somehow got picked up in a different way and reinterpreted in industry. So I think there's a really ongoing complex relationship between the two of them.
Yeah. And it's almost kind of poetic in a sense in that a lot of the media space work presented at the beginning of the session is exactly the type of medium that we're using right now to have this session to talk about it.
So a second question. Oh, please go ahead.
I think, Irene, you need to unmute.
Muted, sorry. I have worried over the years whether we could point to something invented in CSCW that became, you know, the next product. So I was very happy when I heard somebody mention Google Docs or something. But I think there's a lot of value in the user studies as well that's been indirect
structure for thinking about how to value innovation in academia that really takes account of the potential social benefits and harms. So I don't know whether it goes to Mary or Kira, but anyway.
I was going to point out two times when I think the CSCW community realized some of the harms systems were causing and changed course. So one is, if you think around crowd work, right? So we see Amazon Mechanical Turk come in 2005. And for the first couple of years after Turk came out, in the Mackay, UIST, and CSCW communities, we saw a lot of research papers that were really looking at like, how could you get the most work out of Turk for the least money, right? I mean, I remember a paper from the University of Washington that was specifically analyzing that, like how little in terms of cents could you pay people with before you saw quality decrease. And then I think with the paper that Nikki and his colleagues presented around, would I want my child to be a crowd worker? That was a time when the community really stopped and evaluated and said, are we doing the right kind of thing with crowd work? And you saw a big shift after that. And I think another example of that happening in the CSCW community was after the Facebook emotional contagion study, which included our colleagues like Jeff Hancock, who was at Cornell at the time. And that was the study where the Facebook newsfeed included subtle manipulations of more positive or negative posts. And then it was measured how that impacted whether people subsequently posted positive or negative things themselves. And it turned out the general public didn't really understand that the newsfeed was algorithmically generated and felt betrayed and manipulated when they learned about this experiment in the media. And Jeff gave, I thought, a very powerful keynote talk at CSCW following the very negative public backlash to that experiment, in which he really reframed that as a learning moment for the community to think about issues like algorithmic understanding. And Karrie has gone on to do a lot of innovative work in how algorithms can be more transparent to end users and social systems. So I do think our community is responsive to some of these social concerns.
Yeah. And I just want to add a small point. Like, I'm heartened also to see this idea of activism as research in our community. And it's not new. Like in the mid-90s, Batya Friedman, Helen Nissenbaum were talking about, bias in computing, value-sensitive design. And we see researchers like Lily Irani making tools like Turkopticon to help somewhat balance some of the asymmetries. And I see more and more of this work also emphasized by Shoshana Zuboff, who was mentioned earlier in this presentation. This idea of understanding the power balances and how we might maybe manipulate the manipulation, as some people are claiming.
I think there was another question that is just tied to this as a final coda on it, is how do we atone for and rectify these harmful impacts?
I guess I can start there. And I'm sorry to sort of put you on the spot, Michael, but I remember almost this like manifesto you wrote once about how in research we can start by setting an example by paying crowd workers, something more akin to the amount of work they're putting into a lot of this crowd work. And so in a sense, you set the tone for my group, I imagine for other groups as well, in how we conduct our studies. And I think that was more inspirational to us. And it was only later that the IRBs caught on and started, enforcing rules like that. But I think one beginning point is to start by example.
I think another important part is understanding what the harms are. And I want to push back slightly against this idea that harms only happen because there are unintended consequences. Of course, no one wants to design a system that harms other people, but sometimes these systems get embedded in sociopolitical structures that cause that harm. And so I think listening to people who are harmed right now is a really important step into understanding how future systems might harm them as well. I keep thinking about how systems that do location tracking, if anyone had ever talked to someone who was a victim of domestic abuse, they would have explained to us how they might be harmed by that. And so I think a lot about how these harms aren't a hypothetical future, they're happening right now. And so we need to be listening to understand them, and then we can maybe try to mitigate them.
Yeah, and one other interesting point, about CSCW and UIST coming together is I see a lot of work coming out of our communities that's informing policy. And so, technology alone isn't going to solve any problems. We know that every time we introduce something new, we create new problems, and often, technology innovations, create inequalities. But this idea of our work not only resulting in new systems, but resulting in policies, ideally for the better, is a type of deliverable and outcome that maybe we should value more.
And one final question that Arvind Satyanarayan asked, touching on a comment that Hiroshi made about going beyond being there. And I think that paper actually came up in multiple presentations. He asked, have we done a good job of going beyond being there? What's worked well and where have we fallen short? And what are the major remaining and ongoing challenges? So what goes beyond being there?
I think I was in the telecommunication industry for 16 years. They are really fixated. Meeting at same room is the most ideal situation. Why don't we imitate? So maybe fundamentally lack of the visions, how they can really make the leap or jump was something very important. So I think how to really get that from the old dogmas, then ask bold questions is something very important. So I think vision is something most critical from my point of view. That's something I learned from James Holland's papers. Yeah.
Actually going to say something a little different, which is that I think a lot of the work that we do in technology is in these shared media things is a little bit in what we call the horseless carriage stage. I believe it was Jonathan who had that analogy years ago. But the idea is there's a difference between an automobile and a carriage that doesn't have a horse anymore. And so we're trying to do virtual meetings and then we add features to them, and we're trying to do virtual phone calls and we add features to them, rather than stepping back and saying, what is it that we as people do together? We want to think about it. So why are we not designing for the fact that everybody's got a phone and maybe an iPad and a screen here, and that we might have we have multiple devices, we're doing multiple things with multiple kinds of technologies, and we don't build, the commercial systems are not designed.
Hi Casey, this is Tarun.
This is Vinod.
You're on mute.
Oh, yeah. Hi there.
Hi,
Okay.
we're the student volunteers for the session, and we just wanted to ask if there were any specific requirements or instructions for us, as in what we're planning is after the presentation, we will post all the questions from Clouder onto the Google Doc, and you can sort of access them there. Is that okay?
Yes, if you tell me how to access the Google Doc.
Oh, should I just send you a link?
Yes. I don't have one.
Stacy's in the lobby, by the way.
Yes, Stacy Scott needs to be a panelist. Thank you.
I am sending the link to you on Clouder. Is that okay?
Yes.
It should show up in your chats.
Okay.
Yeah.
technical host, I'm guessing that you know there's a video to be played at some point.
Yes, good morning. My name's Drew.
Hi.
I have the video here. So what I have here is obviously the title slide that everyone's seeing right now.
Yep.
The idea is that I'm going to drop that as soon as we kind of start the session so that you can either take over share, or I don't know if you have slides or documents to share, or if you're going primarily webcams. I'm just going to sit in the background and listen for you guys to let me know when you need that video played, and I will launch my screen share back up for that, play the video, and then drop it back down. So
yeah, that's perfect. Yeah, so I'm going to share some slides, talk for maybe like 5 minutes, and then I will tell you to play the video.
Okay, so we're looking at that video being like the first probably 10 minutes or so?
Yes.
Okay.
Great, thank you.
I'm assuming you're the session chair for this.
Yes.
Okay, excellent. I'm going to promote you up to co-host also.
Okay, great.
That gives you administrative rights to promote and demote people as needed. So.
Oh, wonderful. Thank you.
And then do we have all of the members of the panel so far, or are we waiting for anyone else?
We are still waiting for 2 people.
Okay. Good morning, John.
Now you can hear me.
Yep. Good morning, John.
Casey, are you all set to go with that video?
Yes, I think we are all set to go. So I understand.
Yes, I have it loaded up.
Okay. You got one of the good guys as a technical host.
Oh, John, I realized yesterday in a session that I had 2 student volunteers in the room that were with us in Jersey, and at least one of them that was with us in Portland.
Good memory.
Well, they remembered being there specifically. I couldn't remember if Jersey was 18 or 17, but they remembered. So
Jersey was 18?
Yeah.
Yeah.
Stacy, I hope your internet is holding up so far. Guess we'll find out.
If anyone does have bandwidth issues, sometimes what we do is have them mute the cameras and leave the microphones active, kind of as a last resort. That reduces the amount of bandwidth that they need to successfully stream up. So sometimes being able to hear them clearly is better than, the audio chopping up. Ideally, we want the video also, but if we have to make a choice there, sometimes that helps blow over the top of problems.
Okay.
Hi, I just logged into the Zoom channel to let you know that it seems like this is going out as a live stream right now for the UIST CSCW thing, and like everything is live, like your entire conversations and everything on YouTube.
All right.
Good to know.
That's good to know.
Okay, and you can remove me to have the right to speak because I'm also not a panelist. I just wanted to make you aware.
Okay, thank you.